10.6 Equations of Circles. Now, to warm up, we're going to just quickly graph a circle whose center is at -2, 3. That's the center of the circle with a radius of 3. Radius of 3 means 3 units. So I'm going to go 3 units to the right because these ones are easy to find. 3 units down, 3 units to the left. So a circle, by definition, is all the points that are the same distance away from the center. So I got 4 points, but what I'm going to do is I'm going to estimate 3 units this way. Now 3 units this way isn't 1 unit. It's going to be more like this. And I'm going to estimate a few more points so that when I start to draw my circle, it looks a little bit rounder. Now it's not perfect by any means, but it gets the job done. Okay, so that's a circle. Notice how I plotted some points to help me draw. Now, the distance formula, if you remember the distance formula, is square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Square root of that. Now, if I want to know what the length of a radius of a circle is, given that the center is at a point hk, so we're just naming the point hk, the length of the radius then would be the square root of x, my point, minus my other coordinate, x coordinate, h, quantity squared, plus y minus k, quantity squared. So that would be the length of a radius. And now we can actually use this to write the standard equation of a circle. So this is the length of the radius. If I square both sides, my radius squared equals x1. In this case, we only have one x, so I'm just going to call it x, minus h, quantity squared, plus y minus k, quantity squared. So x and y are any point on the circle with a given radius. So we're given a radius, so where r equals the radius, and the center of the circle is at hk. At the center of the circle, notice it's minus h, so if this was a 4, it'd be centered at where x is 4 this way. And you'll see that in a second. Okay, worthwhile to have that in your notes. Now write the standard form of an equation of a circle with center -5, 0. So r squared equals x minus h quantity squared plus y minus k quantity squared. Center is at hk and radius of 4.8. So 4.8 squared equals x minus h, h in this case is -5, quantity squared, plus y minus k, k is 0, quantity squared. And now I can simplify this. 48 squared, so this is 23.04 equals quantity x plus 5 squared plus y squared. Y minus 0 is just y. Subtracting and negative is adding. Okay, so that is my equation of that circle. Now the point 2, 1 is on the circle whose center is for -3. What we need to do is we need to use this to find the radius. So we need to find the length of that side. And I'm a big fan of the Pythagorean theorem to do this stuff. If this is the point 4, -3, and this is the point 2, 1. Might be drawn kind of poorly, but from 2 over to 4, we went over 2 to the right, and from 1 down to -3, we went down 4. From 1 to -3, we dropped 4. 2 to 4, we went over 2. And now I'm going to use my right triangle Pythagorean theorem. 4 squared plus 2 squared equals my hypotenuse squared, or take the square root of it. So my radius is going to equal that. Now you could do the same thing with the distance formula if you didn't like that method. You could plug all those numbers, x1 minus x2 quantity squared plus y1 minus y2 quantity squared, and you'd get the same thing. 2 minus 4 is a -2, but when you square it, it's the same thing as 2 squared. 4 minus -3 is a +4, and when you take the square root, you get 4 plus 16, or the square root of 20. Just like over here, 16 plus 4, square root of 20. Okay, that's my radius, 2 times the square root of 5. Now I can use that to write an equation. R squared equals x minus h quantity squared plus y minus k quantity squared. And in this case, r is 2 times the square root of 5. We're squaring that whole thing. X minus h is the center, hk. So h is 4 plus y minus a -3. Now, this is the same thing as 2 squared times the square root of 5 squared. Square root of 5 squared is just 5. 2 squared is 4. We get back to 20. Notice if I took this answer and squared it, I'd get 20 as well. Square root of 20 squared. X minus 4 plus y, subtracting and negatives, adding, squared. X minus 3 quantity squared plus y plus 1 quantity squared equals 4. If I want to graph this, I need to figure out what r is and where hk is. So remember, the formula is x minus h quantity squared plus y minus k quantity squared equals r squared. So what squared is 4? Well, 2 squared is 4. Take the square root. Undo squaring by taking the square root. And h is going to be 3. And k, since I'm subtracting k, I need to think of this as subtracting a -1. So k is going to be -1. So now I can graph this. My center of my circle is at 3, -1, the radius of 2. So I'm going to go over 2, up 2, down 2. This length looks to be about there. So I add in a few more points to help me make sure I get it round as I start to draw in my circle. Okay, I think this is the last example. Maybe I got one more, but we'll see. Center of this circle. Okay, we want to figure out which point is in the circle. Well, what's the radius of this circle? My radius is going to be 3. So I know I'm looking for which point is in the circle. I know the point has to be within 3 of the center. So the center's at 13.6. How far is the point 5.6 from the center? So I'm actually going to do this without graphing it. I think it works a lot better. You can definitely graph it to get a picture of what's going on. But if I want to check point A is at 0.56. How far is it from 13.6 to 5.6? Now you can use the distance formula or Pythagorean theorem. Changed my x's. I went over 8. From here this way over 8. And I didn't go up or down at all. So this is a distance of 8. So is that inside the circle if it's a radius of 3? No, that doesn't work. Try that again with the point 14.8. 14.8. Okay, I went 1 in the x direction, and I went up 2. So what is the length of that segment? How far away from the center of the circle is that point? Using a Pythagorean theorem, 1 squared plus 2 squared, I get the square root of 5, which square root of 9 is 3. So I know this is less than 3. So I know this point is inside the circle. And then lastly, 29. How far is that from 13.6? Well, I'm going 7 in the x direction, 3 in the y direction. That means this point in the center of the circle is going to be 7 squared plus 3 squared, or 49 plus 9. It's going to be the square root. Okay, this squared plus that squared equals that squared. So I have to take the square root of 58. And I know that the square root of 49 is 7. So I know this is more than 7. So my circle has only got a radius of 3. That one is going to be on the outside. So this is the point that is on the inside of that circle. This one's just like an earlier example. You can skip it, or maybe if you need to see another example, here's an opportunity. But I need to figure out my radius first. So I have to figure out what's the distance from this point to this point. So in my x direction, I went from 0 to -4. That's the length of 4. My y direction, I went from -1 up to 1. So that's a length of 2. So my radius, okay, my radius is going to be 4 squared plus 2 squared, or 16 plus 4 square root of 20. Plugging it into the formula, r squared equals x minus h quantity squared plus y minus k quantity squared. Okay, using this as hk, the center of my circle. Square root of 20 squared is 20. X minus h is -4, so subtracting a -4, same thing as adding, plus y minus k is 1 squared. There's your homework assignment. I'll see you after a while, crocodile.